Okay, this is it. Chapter 3 review. So this is the polynomial review. I want to quickly go through some of these questions. Well, a lot of these are questions you probably already know how to do, but I just want to make sure that we understand it before the test. So here is a quick chart to fill in. The degree, remember the degree of the polynomial is just its highest power. So this one's degree 4. Now luckily these ones are all in descending power, so I'm just looking for the first term. Degree 5, degree 3, there is no x. Well, it's really x to the power of 0. So this is considered to be a degree 0. Type, well, this is a cubic. We know that this is a constant, right? It's not, well, it is a line, but it's a flat horizontal line, so it's considered a constant, a special kind of line. This would be a quartic and a quintic. Quintic, quartic. Not that that's really important. Parabolas, quadratics, and cubics are our most common ones we see. Okay, leading coefficient, meaning that -2, +3. Leading coefficient is 0.5. And the leading coefficient is the only one, it's 10. It's also the constant term, right? So the leading coefficient is, in this case, it's the same one. The constant on the end here, there's a constant. The constant is a number. It should be a number. So here it's 3, and here it's -7, right? Okay. So for each of these ones, it says, determine whether or not the graph represents an odd or an even. Well, first off, this one, they're in the same direction. So first and foremost, I know this one's even, period. Same direction. As soon as they put arrows on there, that means it's just going to continue on in the same pattern. It means doesn't change concavity, doesn't change increasing, decreasing, any of that stuff. Is the leading coefficient positive or negative? Look at the right-hand side. This is going down to negative infinity, which means it's got to be negative. State the number of x-intercepts. 1, 2. There's 2 x-intercepts. These are both single roots, right? Because they cross right over, and it doesn't really change its concavity. Like something like this would be, but no, there's 1, 2. There's only 2 of them. And the domain and range? Well, the domain for all of these is going to be all real numbers, unless you actually stop it, because this is going to continue down forever and continue spreading off to the right. However, the range, in this case, is going to be the y value of 19 and below. So the range is going to be y values less than or equal to 19. Okay, let's try this one over here. Even or odd, they're in opposite directions. So this one is definitely odd. And the leading coefficient, this thing goes up to positive. Remember, we only look at the right-hand side, because the left-hand side depends if this is odd or even. It could be going up or down, but this one's going to be positive. So the leading coefficient is positive because it goes up to positive infinity. Okay, number of x-intercepts, 1, 2, 3. There are 3 x-intercepts. Now, hang on. I know that this is a triple root in the center, but it's still an intercept. So there are 3 x-intercepts. If I had to guess the equation, single root, triple root. But I'm not doing that. Domain of range, for both of these, it's going to be all real numbers because it continues, left and right forever, also up and down forever. Oh yeah, all odd degree polynomials have domain and range equal to all real numbers for both of them. Okay. Who's next? It says, the distance d in meters traveled by a boat from the moment it leaves shore can be modeled by this function. Okay, so blah, 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 where t is in seconds. I'm assuming that time is probably greater than or equal to 0, right? It doesn't say anything about negative t's. So what is the degree of this function? Degree 3. Done. What are the leading coefficient? Okay, the leading coefficient is 0.002. Go away. And what is the constant? Oh, the constant on the end is 0. Okay, what does that represent? Well, at time 0, that means your initial position, right? So initial position. So in other words, if I could spell, let's see. Initial position. And that really just means at time 0, its position is 0. So it's starting at 0. That's all this really means. Describe the end behavior. Well, let's see. It's positive. So as I go to the right, it should go up to infinity. Or in other words, I could say the limit is x goes to infinity. It's not x, it's actually t. Careful. is infinity, right? Well, sorry, I should put d in here. The limit as t goes to infinity of d of t is equal to infinity. So it goes up to infinity. Does it? If this is a positive, it should. Now, what about the limit as xt, once again, as t approaches negative infinity? It's odd, so it should go down to infinity, right? No, hang on, stop. This thing can't go into the negatives. It cannot go to negative infinity. It doesn't go on to the left forever. It stops at time 0. So this is wrong. I shouldn't be doing that. So this is the right-hand side. And the left-hand side, at time 0, it's actually equal to 0. As t approaches 0, right, position d approaches 0. So the left hand, it stops at d equal to 0. So in other words, it has an end point. It stops there if you're moving backwards in time, or in other words, you could say it starts there, right? So this isn't a full polynomial off with a domain of all real numbers. So we're restrictions, there we go. Where's the restrictions on the domain? Time has to be greater than or equal to 0. Explain why you selected this. Well, if we're talking about the time from the moment it leaves the shore, we're not talking about previous time. Are there any restrictions on D? Well, this thing seems to keep going. Now, D can't really go to infinity because we live in a finite world, right? But is D less than or equal to something? We don't know a number, so I can't really put a restriction on there yet. But I know that D can't really go to infinity. You can't get an infinite amount away from something. Okay, what distance has the boat traveled after 15 seconds? This is just a matter of plugging in 15, right? D of 15, that's all this is. D of 15 means it's going to be 0.002, 15 cubed, plus 0.05, 15 squared, plus 0.3 times 15. So whatever that works out to be. 22.5. Okay, 22.5 meters. It says, make a sketch of what you think the functions looks like, and then graph it using technology. Well, I'd have to factor this thing, and you know what? I'm not going to factor this thing. If we were to graph this thing using technology, come on, let's use our graphing calculators effectively. If we actually graph this thing, right, and you look at it, what does this thing look like? It looks something like this. Doop. And then it goes through 0, and then it keeps going on. This is the only part of the graph that exists, because this part doesn't. What? Think about it. This part shouldn't exist. Even though if you graph this thing, if you look at it, it looks something like this, I believe. Boop. This part of the graph should not exist. It shouldn't be here. Okay? So that's, this part of the graph exists, and this part doesn't. Okay. Let's get back into the next question. Okay. Doop. So the remainder, no, that's not what we're doing here. Remainder theorem. Okay, let's do this one. Doop. Go away. Okay, remainder theorem. Let's do this. So it says use long division to divide this thing. We could use synthetic division. This is a 1x. Synthetic would work fantastic. Maybe we should do that. Should we do long division? I'm going to cheat. The only time I use long division is if it's like a 2x plus 3, right? If it's a leading coefficient that's not 1. Because I know that the shortcut for this is going to be what? 5, negative 7, negative 1, 6. Those are my 4 coefficients. And instead of x minus 1, I'm going to put a positive 1. So 5 comes down. 1 times 5, 5. Add them up, negative 2. 1 times negative 2, negative 2. Add them up, negative 3. 1 times negative 3, negative 3. Add them up, 3. So this becomes the remainder. And this becomes the quotient. And it says express in this form. Well, the polynomial, which is 5x cubed minus 7x squared minus x plus 6, when it's divided by my divisor, which is x minus 1, it should equal the quotient, which is number x squared, right? 5x squared minus 2x minus 3 plus the remainder, which was 3, out of my divisor, x minus 1. And it says identify any restrictions on the variable. Well, if I'm dividing by this, x minus 1, x cannot equal positive 1. Because if I did, that's where I'm actually going to be getting divide by 0. Right? So I can divide by anything, I just can't divide by 0. Okay, write the corresponding statement that can be used to check the division. So in other words, if I was to multiply this out, remember, it'd be the divisor times the quotient. Really, if you think about this, if I multiply this up here, cancels out there, and it multiplies onto this one. Okay, so in other words, the polynomial is the divisor, x minus 1, times the quotient. And there it is. 5x squared minus 2x minus 3. And then once I've expanded that all out, I've also got my remainder, plus 3. So this is just a different way of writing it, right? Polynomial divided by divisor is the quotient, and the remainder out of the divisor compared to this one. Polynomial is the x minus a times the quotient plus remainder. Okay, determine the remainder after the division. So if I'm looking for the remainder, I'm really looking for, I'm looking for what is it when I plug in negative 3. So negative 3 cubed, negative 27. Plus 2 times negative 3 squared, 9. Minus 3 times negative 3, plus 9. So what am I going to get? I'm going to get minus 9 plus 9. These two cancel. So I'm going to get negative 27 plus 18, which is negative 9. So the remainder should just equal negative 9. How about this one? I'm plugging in negative 2. So 2 times negative 8 plus 7 times 4 minus 2 plus 1. Okay, so minus 16 plus 14 plus 2. There's 16 and 16 gone. Plus 1. Should just be 1. Oh, hang on. 2 times, not 14. Silly. This is 28. So add on 14. So this should be 15. There we go. Okay, now what? I'm plugging in positive 3. 3 cubed, 27. 2 times 9, 18. Minus 9 plus 5. This is all we're doing. Okay, so what have we got? 45 plus 5 is 50. 50 minus 9 is 41. And then the last one, I'm plugging in positive 4. So 4 to the power of 4, that's 256. So that's 120, 2 times 256 plus 7 times 16 minus 32 plus 3. Okay, this turns out to be 595. Okay, fair enough. Determine the value of m such that this thing, when divided by x minus 2, the remainder is 8. So in other words, if I take positive 2 and plug it into here, so f of 2, the remainder should equal negative 8. So here we go. I'm going to plug in positive 2 into this equation and know that it equals negative 8. So positive 2, 2 to the power of 4 is 16 minus m times 8 plus 14 minus 6. Okay, so 30, I've got 24, minus off 24, I'm going to get minus 32 is equal to negative 8m. In other words, m should equal positive 4. Okay, use the value of m to determine the remainder if it's divided by this. Okay, so minus 2, I'm going to be plugging it into, if this, so if this thing is being divided by the, okay, so if I'm looking for the remainder, I'm plugging in negative 2. So negative 2, I'm going to plug it in. So what's f of negative 2? It's going to be negative 2 to the power, so it's 16 minus m is 4, and negative 2 cubed is negative 8, plus 7 times negative 2 minus 6. Okay, so what do we got? We got 16 plus 32 minus 14 minus 6. In other words, that turns out to be 32, 2 minus 6, negative 4. Hang on, is that negative 4? Did I do that right? No, I didn't do that right. Okay, let's add these up. Add these up correctly. 48 minus 20 should give me 28. There we go. Way better. How about this one? When the polynomial is divided by x minus 2, so in other words, plug in positive 2, the quotient is this, and the remainder is that. What is the polynomial? Oh, I remember. The polynomial is the divisor times the quotient plus the remainder, minus 4. So expand this all out by FOIL and superFOIL. Let's see, we're going to get x cubed. What else are we going to get? We're going to get minus 2x squared plus 4x squared. So plus 2x squared. We're going to get minus 7x minus 8x. That's minus 15x. And then what do we get on the end? We're going to get plus 14, but then minus 4, which is plus 10. That should be our polynomial if we expand the whole thing all out. Okay. Next, the factor theorem. Remember, it says if you plug in the opposite number and if it equals 0, it's a factor. So what corresponding binomial factor? If I plug in 7, that means x minus 7 is a factor. It is a factor. If I plug in p minus 6, so that means x plus 6 is a factor. In other words, if I was to take x plus 6 and divide it into whatever the polynomial is, it should give me 0. 0 as a remainder. And p of c, this means that x minus c. So c might be a positive or a negative, but it's just going to be minus. It's going to be the opposite, is a factor. So determine whether x plus 2. In other words, I'm going to plug in negative 2. Let's plug in negative 2. I get negative 8 plus 2 times 4, which is 8. Minus 2, which is plus 2, and then minus 2. 0, 0. 0, yes, it is a factor. Let's take negative 2, plug it into here. I bet you this one doesn't work. Let's see. 16 plus 2 times negative 8 minus 4 times 2 squared is going to be 4 plus negative 2 plus 10. So what do we get? We get 16 minus 16. Those are gone. So I got minus 16 minus 2 plus 10, which is minus 8. This is negative 8, which means no, it is not a factor. Oh, so it doesn't matter what this number is. As long as it's not 0, that means there is a remainder. Okay. How about this? What are the possible integral zeros? So in other words, if I was going to be making my guesses, what are my possibilities? Possible, not the actual ones. I know that there's 3 actual ones, perhaps, but the possibilities I'd be guessing are plus or minus 1 and 27. What else? 3 and 9. 4 doesn't divide in. 5 doesn't divide in. 6 doesn't. 6, 7, 8. That's it. Those are the only ones. So, doop, there is it. That's the entire collection of possibilities. There's only 8 possibilities. Those are them. So once again, 36. Look at the number on the end. Plus or minus 1, 2, 3, 4. Yeah. 5 doesn't divide in. 6, yes, of course 6 divides in. And 6 times 6 is, oh yeah, 6 times 6 is 36. That's the middle number. So which one goes with 9? Or so, with 4? 9. Which one goes with 3? 12. Which one goes with 2? 18. Oh yeah. And 1 times 36. 1, 2, 3, 4, 5, 6, 7, 8, 9. So times 2, there's 18 possibilities. Okay, so let's do some factoring. I know my possibility, I don't have enough room here. On a question like this on a test, I'd give you like a whole page to do this. So you don't really need it, but I'm going to say my possibilities, first off, are going to be plus or minus 1, 2, 3, and 6. We know that. Now, if I actually plug in p of 1, if this is my polynomial, p of 1 turns out to give me 1 plus 1, 2, minus 4. No, p of 1 is not going to work. Does not work. What about p of negative 1? So negative 1 minus 4 minus 1 plus 6. That's negative 6. Ah, this one works. So p of negative 1 will give me 0, equals 0, which means x plus 1 is a factor. That's important. That's so important that I should actually state it. It's important to know. That means I know that it divides in. So let's divide it in by synthetic division. So 1, negative 4, 1, 6. Okay, so 1 comes down. Negative 1, add them up, negative 5. Positive 5, add them up, 6. Negative 6, add them up, 0. Good. I know this has got to be 0. It's my remainder. So in other words, the polynomial is going to be x plus 1. There's my first factor. And here's the other one, x squared. X squared minus 5x plus 6. I recognize this. This is a trinomial. X minus 2, x minus 3. X plus 1. You remember, two numbers multiplied to 6, they're either both positive or both negative. They're both negative because they add up to a minus. So there it is. That's what it is factored. Okay, so what is x equal to? X is equal to negative 1 or 2 or 3, right? Wrong. This is not an equation. It's not equal to anything. It says factor. I've factored it. Stop. If I do this, I'm solving an equation. Don't do this. That's not right. No, no, no. In fact, that's now wrong. You've now done the question wrong, even though this is good. So factored, factored. If it was equal to 0, yes, I would do that extra step. However, it isn't. So what are the marks here? We don't want that. Get rid of this stuff. A 4-mark question. Whoa, probably 1 for your possibilities, probably 1 for stating that I found my first factor, because I know that you're going to be using your calculator. 1 for doing either long division, synthetic division, getting the correct quotient here, and we know this has to be 0. And then stating that the polynomial is the divisor times the quotient, and then breaking it down. This would be a 4-marker. Okay, let's try another one here. Once again, my possibilities are going to be plus or minus 1, 2, 4, 8, right? If I plug in p of 1, I'm going to get 8 minus, no, 1 does not work. What about negative 1? 3 times negative 1. So negative 3 plus 5 plus 26 minus 8. That does not give me, no, negative 1 does not work. You don't have to show the ones that don't work, because I know there's going to be lots that don't work. Now, turns out that p of negative 2 actually works, which means x plus 2 is a factor. Factor. Yay, that's important, which means I know I can do my synthetic division. Let's do it. 3, negative 5, negative 26, negative 8. Okay, 3 comes down. 2 times 3, which is 6, add them up, 1. 2 times 1, 2, add them up, negative 24. 2 times, hang on, something's not working here. Should this be a positive 2? This should be a negative 2. How do I know? Because I'm not going to get a 0 here. Okay, yeah. So hang on, let's back this up. Doop, 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 doop. This is negative 8. This should be minus 2 because x plus 2. Okay, 3 comes down. Negative 6, add them up, negative 11. Positive 22, add them up, negative 4. This is working better. There we go. I can see I get positive 8, yes, and which means my remainder is 0. Cool. Okay, so this is my quotient. So, in other words, this thing is going to be x plus 2, and my quotient is going to be 3x squared minus 11x minus 4. Okay, so this I can probably break down. I can do it by decomposition. Two numbers that multiply to give me negative 12, and they add up to give me negative 11. It's got to be 12 and 1, negative 12. Now, instead of doing the whole thing by decomposition, I'm willing to bet you can probably figure this one out. I'm willing to bet you can probably guess it. Because look, 3x squared, you know it's got to be 3x and 1x, because we're not looking for fractions. Okay, so 4, it's either 2 and 2, or it's 1 and 4, and it's minus. So hang on, this would give me minus 2 and minus 6 is going to be a difference of 4. No, it's not 2 and 1. It's got to be 4. It's not 2 and 2. It's got to be 4 and 1. Okay, do you want to do it as 1 and All right, let's try it 4 and 1. If I was to do that, I'm going to get 4x and 3x. That's 7x or different. No, that's not it. So you can probably guess this. Try it the other way around. 4 and 1. Yes. Now we're going to get 12x and 1x. So it's got to be minus. Minus 12x. No. I want it to be positive 12x. So that's a plus. That's a minus. Hang on, does this work? We know 3x squared. We know minus 1 times minus 1's minus 1. And this is going to give me positive 12 minus 1. I want it to be the other way around. There we go. So you can usually guess these pretty quickly. And then don't forget, I got the x plus 2 out front. Something like from here to here, you don't need to show that work because that's grade 11 concept, right? You can do decomposition where you split this into 2. Yeah, but you know what? Seeing as you have a limited number of possibilities here, it might be faster to guess it. Okay, look at this beast. Plus or minus 1, 2, 3, 4, 6, 9, what was it? 12, 18, 36. Yikes, there's lots of possible factors, right? So luckily, our first one, P of 1, works. P of 1 is equal to 0. Excellent. So that means x minus 1 is a factor. Okay, so I'm going to take positive 1 out front. While I'm plugging this into my calculator, you know what? I know I'm going to have to do this twice because it's x to the 4, which means it's x to the 3. I got to do it again. So you know what? I plugged in a few of these. I found that positive 1 gave me a 0, and I also found that P of 3 gave me a 0, which means I know that x minus 3 is also a factor. Okay, well, let's do this one first. Here we go. So positive 1 goes out front. What do we got? We got 5, 12, negative 101, 48, and 36. Remember, they've got to be in the right order. And if there's a 0, we got to put them in. 1, 2, 3, 4. We're good. 5 comes down, 5. 17 comes down, 17. Okay, so negative 101 plus 17, negative 84. Negative 84. This is going to give me negative 36. Hey, nice. Negative 36, 0. There's my remainder. Okay, so I know that the polynomial is x minus 1 times this. X squared, x cubed. 5x cubed, 17x squared, minus 84x, minus 36. Okay, now I got to start over. No, you don't have to start over. I remember that P of 3 gave me a 0, which means x minus 3 is a factor of this, which means it's one of the factors in here because it's not that one. It's got to be built into here. So I know that x minus 3 should factor into this one as well. So let's do synthetic division. And we're going to do it for this polynomial with the minus 3, positive 3 out front. So what do we got? 5, 17. 5, 17. Negative 84. Negative 36. Okay, here we go. 15. Add them up. 32. 96. Add them up. That gives me positive 12. Hey. 36. Add them up. 0. There we go. So I know that this thing turns out to be x minus 1. Yeah, I'm really cramped for space here. X minus 3. 5x squared plus 32x plus 12. Okay, now this one, once again, this one I can break down by, let's see, two numbers that multiply to equal 60, and they add up to 32. Wouldn't that be 30 and 2? 5x squared plus 30x plus 2x, and then plus 12. Whew. I can divide out 5x. 5x, bracket, x plus 6. Here I can divide out 2. 2, bracket, x plus 6. Okay, so one of my factors is x plus 6. There it is. And the other factor is going to be 5x plus 2. You know what? I'm just going to get rid of this stuff here. I know that that's what this is going to turn into. X plus 6 and 5x plus 2. So that's what this thing factors into. Go away, go away, go away, go away. Do you need to show that work? No. But we do need to remember this. Why don't you just use the quadratic formula? This isn't an equation. Remember, we're factoring. So this beast, to the power of 4, I was expecting 4 factors, and I got them. Now remember, x, 5x, 5x to the 4, right? -1, -3, multiply that makes positive 3, 18 times 2, 36. There it is. All the other ones, it's kind of whatever inside. Okay. Last one. Oh man, this one's going to be a beast. Possibilities are 0. Factor out your first x. Remember, they're all divisible by x. So let's do that. 2x cubed, 5x squared, 8x minus 20. There, that's better. So the number on the end, my 20, possibilities are plus or minus 1, 2, 4, 5, 10, and 20. Okay, so plug in 1, 2, and 5 is 7 minus 28. 1 does not work. Neither does -1. However, P of 2 does. So in other words, x minus 2 is a factor. Remember? Step 1, step 2. Now I know that positive 2 is going to go out front. I'm going into this polynomial, right? Because I already pulled out the x. So 2, 5, -8, -20. 2 comes down. 2 times 2 is 4. Add them up. 9. 2 times 9, 18. Add them up. 10. 2 times 10, 20. Add them up. Excellent. That's what I was expecting. 2x squared, 9x, and 10. So my polynomial is going to be x bracket 2x squared plus 9x plus 10. Two numbers and multiply to give me 20 and add up to 9. It's got to be x plus 4, x plus 5. Cool. I know that's right. No, that's wrong. You know that's wrong. Why? Because x times x does not give me 2x. Oh, this can't be. Oh no, this is where I have to break this into these two and these two. Yes, that's right. You have to do the decomposition. It's not just a shortcut one. Could we guess it? Maybe we should guess it. Well, could we? Let's try guessing it. Because I know there's going to be 2x and 1x, period, right? 2x, 1x. Okay, so this is either 10 and 1. Will that work? If I go 10 and 1, that's going to give me 10x and 2x is 8. Nope, that's not. What if I go 1 and, no, that's going to give me 20 and 1. No, that's even worse. So it's not 10 and 1. Is it 5 and 2? Plus 5 plus 2. Hang on. That's going to give me 5x and 4x is 9x. Hey, that works. And they're both plus. See? They're not that hard to guess if you have a limited number of them. I could have done this by decomposition as well. Okay. How about this one? What does it say? It says rectangular ice blocks are cut up and used to build the front entrance of an ice castle. Volume is given by this. Whoa, there's the volume. It's a cubic because it's cubic. Okay, that makes sense. What are the factors that represent possible? And they say x is a positive real number. Okay, so in other words, they just want us to factor this thing. Okay, possibilities, plus or minus 1, 2, and 4. Okay, so if I actually use v of 1 equals 0. So therefore, x minus 1 is a factor. So let's do it. Positive 1 goes out front. And it's 5, 7, -8, -4. 5, 7, -8, -4. Okay, 5 comes down. 1 times 5, 5, 12. 1 times 12, 4. 1 times 4, 4. 0. Nice. Good. So here's what v is. V of x turns out to be x minus 1 times 5x squared plus 12x plus 4. Okay? Two numbers that multiply to give you 20, and they add up to give you 12. 2 and 10. I could try guessing this one. Oh, let's just do it because I can see this. I can see the pattern right now. 5x squared. I'll put the 10 right beside it because I know they have 10 and they both have 5 in common. So 10 and 2 and 4. These have 2 in common, these have 5 in common. So in other words, this is going to be 5x bracket x plus 2 bracket x plus 2. Oh yeah, I should probably say, okay, this is all times x minus 1. So here's what it is. V of x is x minus 1, x minus 2, or sorry, x plus 2 is a factor, and 5x plus 2, 5x plus 2 is also a factor. So that's what it is if you factor this whole thing. And what is it saying? Does it say anything about whole numbers? Positive real numbers. They got to be positive. What are the factors that represent possible dimensions in terms of x? There they are. There's my 3 factors. So it's really my length, width, and height. If they're talking about a 3-dimensional volume thing. Yeah, it's probably a length, width, and height. Okay, let's get into the last page here. So equations and graphs. So now we're looking at double and triple roots and stuff like that. So least possible degree. Well, let's see. I'm assuming that's a triple root. And that's a turning point, and that's a turning point. So usually, as soon as there's a turning point, that's degree 2. Now it's degree 3. And then 4, 5, 6. There's probably a triple root here and a single root there. It's probably degree 4. It can't be 4. Why not? Because they're in opposite directions. So it's got to be at least 5. How do you know that? Well, because I know it's got to be odd. So the least possible, so it might be 5, might be 7, you never know, but it can't be even. So I know it's got to be at least degree 5. Side of the leading coefficient, look at the right-hand side, negative. Negative, because it's going down to infinity. The x-intercepts, negative 3 has a multiplicity of 2. Oh, that's why it's a double root. And positive 1 has a multiplicity of 3. So x equal to negative 3, multiplicity of 2. X equal to positive 1, that one has a multiplicity of 3. It's a triple root. A single root crosses over, right? A double root is tangent. And then the triple root is like an inflection kind of shape. Okay. Who's next? Intervals where it's positive, where it's negative. That's kind of unnecessary. We know where it's positive. Above. Then it's negative. So it's negative everywhere to the right of 1 and everywhere to the left of 1 except for this 1 point. That's not negative, it's actually equal to 0. So where is it positive and where is this negative? Who cares? It's not an important thing. The equation of the polynomial function. Ooh, how do I do the equation of this thing? Well, I know I've got a triple root at here, so this is going to be x minus 1 cubed. And I know I've got a double root here at x plus 3 squared. I just don't know this. I do know it's got to be negative. If I knew an actual x and y point, I could plug it in. So the roots are not good, but this one right here, that's the point I'm going to use. So this is the point 0, 2. So in other words, the y-intercept is positive 2. So if I was to actually plug in 2 and 0, let's see, what do I get? Negative 1 cubed, which is negative 1. 0 times, this is 3 squared, which is 9. So this is going to be negative 2/9. Whoa. K turns out to be negative 2/9. If you think about it, because I'm plugging in, right? I'm plugging in the x value of 0, and I'm getting the y value of 2. So if that's exactly 2, K should be negative 2/9. It's hard to see, isn't it? Oh, hang on. 9, 9, 9. So let's just actually do that here. I know that K's got to be negative 2/9. On a test or something like that, I wouldn't have you estimate that because, to be honest, is that 2 or is that 2 1/4? It's kind of hard to see, right? I would give you a dead on point, and that way you could. Otherwise, if you said it was 2 1/4, you're actually going to get a different value here. Okay, I think you'd get like 1/4 because it was, yeah. Okay, let's try this one. Double root. Single root. So this thing's probably degree 1, 1, 1, 2. Probably degree 4. Hey, that completely makes sense because it's even. So I know it's degree 4. Leading coefficient, positive. I know, because the right-hand side goes up to infinity. The left-hand side is going to do the same because it's even. See, the left-hand side does the opposite because it's odd. X-intercepts and their multiplicity. Well, has an x-intercept of -2. X equals -2 has a multiplicity of 1. X equal to -1/2 also has a multiplicity of 1. And x is equal to 2. Multiplicity of 2. Okay, where is it positive and negative? We can see this. It's not an important question. Here's where it's positive. Here's where it's positive. The entire interval from -1/2 on, except for the point 2. And here is where it's negative, right? Negative between here and here. Big deal. Not a huge deal. But the equation, okay, this is going to be the huge deal. So I know it's going to be y is equal to -2, so that should be x plus 2, single root. X minus 1/2, we could also just do 2x plus 1, right? Because that represents -1/2. Oh yeah, so that way I don't have to deal with fractions. You could do it either way. Okay, and then what about this one? X minus 2, and it's squared. Okay, that one gave me a dead-on point. When the x value is 0, my y value was 4. Oh, I didn't see this point over here. That's probably the point I wanted to use. I probably could have used -1/8. Yeah, it probably would have given me a better value. Okay, but let's use this one, 0, 4. Okay. When the y value was 4, the x value was 0. So I got to figure out what k is. Okay, this is going to give me 2, 1, and this is 2 squared is 4. So in other words, 8k is going to be 1/2. Positive? Yes, positive, because it's going in the positive direction. So here we go. Y is equal to 1/2 x plus 2, 2x plus 1, x minus 2 squared. If I had used x plus 1/2 here, I think I probably would have got 1, right? But either way. Okay, last one here. Given this function, x to the power 5, list the parameters of the transform polynomial. Yikes, this beast. Describe how each does the transformation. Okay, well, let's see. I know that this thing's been moved sideways and up and down. However, I should probably do the vertical and stuff. Okay, so I know this is a vertical reflection, right? Flipping it upside down. Okay. And it's a vertical stretch of 2. So it makes it twice as tall. What about this? This is touching the x, right? Oh yeah. So it's going to be a horizontal. It's not a reflection. It's not negative here. That would flip it sideways. No, it's not doing that. This is flipping it up and down, right? So there's no negative here. Okay, so it's not going to be a horizontal reflection. However, it is a horizontal stretch, and it's 3 times as wide. Horizontal expansion, or you could say stretch of 3. Stretch is equal to 3. Okay, done, done. And then I'm moving it 1 to the right, up 4. So the vertex, or the translations, 1 to the right, 4 up. Done. Now you do these ones first and then these ones last. Determine the domain and range. Hang on, this thing's an odd. And if it doesn't tell you anything, it's going to be all real numbers for everything, for both. Why? Because remember, odds, they go in one direction and the other. And there's nothing restraining the x, right? X value could be anything. There's no square roots, there's no radicals, there's no nothing. X could be anything. So it's kind of boring. It's going to be the domain and range for most of these polynomials is all real numbers for both of them. Okay, last one. Determine the equation with the least degree of a cubic. Okay, they told you it's a cubic. Okay, the zeros are here, multiplicity of 2, and here, the y-intercept. Okay, so I know that y is equal to k. 0 is at -2, so x plus 2, and it has multiplicity 2, and x equal to 3. X minus 3, multiplicity of 1. So I know that that's a cubic. The y-intercept is 36. So in other words, that means x equals 0. Y-intercept is telling you x is equal to 0. Plug in 0. Plug in 36. 36 is equal to k times 0 plus 2, so 2 squared, which is 4, and 0 minus 3, which is minus 3, minus 12. K is going to equal negative 3. I'm not done. I actually need to write it out. Here we go. Y is equal to negative 3, bracket, x plus 2 squared, bracket, x minus 3. There's my polynomial function. A question like this would probably be worth 2 marks or 3, depending upon the degree of difficulty. The answer is not the important part. Here's the important stuff. What are we looking for? Do you have the correct roots? So you didn't put in x minus 2. You got x plus 2. You know it's the opposite. And do you have the correct multiplicity? It's 2. Oh yeah, not 1. So this would be a mark for having, so probably half mark, having the correct roots and in factored form. We don't need to expand this stuff all out. Don't bother. Okay. What else are we looking for? K. K is super important. A lot of people forget to put K in. They just do this. Oh, there it is. You're telling me that K is equal to 1, and that's not true. So hang on, let's bring that back. K is a mark, right? I have to know that the stretch is there. And in the same way, when I plug in my X and Y value, now I'm actually figuring out. So it's probably like half mark, right? Actually getting this. This would be a third mark. Ooh, yeah. So I actually figured out what the, what's another better one? Oh, let's go light blue. I actually figured out the stretch was minus 3. Half mark. You actually have to write it. So figuring out the stretch is good, yes. However, now I need to actually answer the question. There's my answer. Ooh, I'm making a mess out of this thing. There's my answer. It's going to be y is equal to this. Alrighty, so that is a long review. And yes, you'll notice the answers are all online. So good luck with this. And sometime this weekend, let's get this last test over and done with, and then summer can begin.